Hello and welcome to 23rd lecture of the course on corrosion, environmental degradation and surface engineering. In this lecture, we will be describing on a principal component analysis PCA. This topic has been already dealt in 2 lectures, but I felt that we should give one complete dedicated lecture on PCA. So, that is why the topic of this lecture has been kept as a principal component analysis. So, why this is really important? We say in these days processing power has increased, or computer processing power has increased. We can really analyze a number of data with several data in very short span of time. Earlier we did not have this kind of facilities. So, that is why we were restricting ourselves on the data, graphs, and then much lesser we say that data which can which were required for the decision making. Now, we want to really analyze many data and take a quick decision based on some sort of mathematics or maybe statistical methods, and PCA is one of the statistical method which we are going to describe. So, in increasing processing power, now it has made possible to utilize vast amount of data. That is what I mentioned. Earlier we did not have this kind of computational power, so we were not able to analyze those data, but now we are able to analyze those data. And then earlier we were confined to lesser computational knowledge or maybe the processing. That is why the most of data were kept in archives. If you look at the data, maybe the data book, people use once in a while. What we are trying to emphasize that we should have more and more utilization of the existing data or previous data. So, the future decision making can be much better. How it is possible? To by exploring hidden connections. Whenever you want to go for the more and more innovation, actually we need to learn what mistakes were done earlier, or maybe if there are number of data, analyze those data, find out the relation, so that we can move further, or maybe we can enhance that knowledge instead of repeating the knowledge or maybe only delta incrementing the knowledge. We want really quantum jump. So, that is why these methods are important, or this kind of methods are important. Now, another thing comes whether do we really understand each data from a physics point of view may not be easy to understand, but at least it will give something different. So, that is why I say that even if a physical meaning is opaque or not very clear to us what data we are getting, but combination of observed factor, this is what we say practical knowledge or observed data which are available, if we can combine or we can utilize, and then it will give a really more effective foundation for discoveries. So, here we can even though we know very well that physics comes first and the maths after that. However, in this case we are saying in maybe we have data, we develop the mathematics first and then we try to figure out the physics behind that. So, it will be allowing us to discover new inventions, and then will be very useful for the society. Another thing in this in the slide has been mentioned, the PCA can be carried out utilizing the covariance, and here basically we are trying to differentiate that the correlation, covariance and correlation, in the sense we are trying to figure out what is the relation between the variables which we selected sometime, right. Sometime we selected time, sometime we selected time in hours or days or seconds and the minutes or seconds. What there were was there any relation with a scale factor also. Those things can be analyzed with a PCA. And in fact, another thing which we have been emphasized here, that we will be able to find new variables which can be adaptive. Most of the time we do experiment keeping in mind, oh, these are the variable, RPM is a variable, load is a variable, stress is a variable, and then those variables have been already decided or pre-decided, while PCA helps us to figure out what will be the variable by the data, by analyzing the data. So, new variables also may be figure out, maybe it can be non-dimensional number, maybe having a and then containing 4-5 variables in a one variable, possibilities are there, but it will really be able to provide a new variable, and what we are using the word adaptive new variable. As a data set change, quite possible the variable will change, of which what we are using the word principal component, that is a main component which has a main impact on the overall process. And this adaptive new variable can be extracted from a data set, which is just opposite compared to the earlier approaches, where we used to have a predefined basis function, predefined basis variables. In addition, this kind of analysis can reduce the noise, and many times we get a lot of noise. Of course, we know the frequency analysis can be done, time training can be done, but PCA is another one which can be really very useful. Now, how we take so many factors into account, because we say that we can have many factors without worrying too much. For that purpose, what we do at the beginning itself, we try to standardize all the variables, and standardize in this manner that it has a 0 mean value and unit standard deviation or unit variance. So, these are the important aspects when we start a principal component analysis or PCA, and of course, there are some limitations. We will be describing those limitations also in this lecture. It is not that it is always a win-win situation with the PCA, it has a number of limitations, or maybe there are a few limitations which we will be addressing in this lecture. Now, what are the steps when we think about solving or maybe going ahead with the PCA? We say first thing, as my previous slide mentioned, standardize a range of a variable. Now, here the assumption is that we are talking about the continuous variables. There is an assumption, even though we are dealing with a discrete variables, but we are assuming these variables are continuous, so that standard or normal distribution can also be utilized. And after once it is done, then we try to make a covariance matrix. And then what is the really relevance of the covariance matrix? We try to figure out relations. So, if there are 4 variables, naturally we will try to figure out what are the relation among these 4 variables, right. What is the relation between factor 1 and factor 2, factor 2 and factor 3, factor 3 and factor 4, factor 4 and factor 1. This is something like that, which is what we really required kind of a covariance matrix. And in we already explained that in our course, the MATLAB will be available with all the students, or the concerned company will be providing the MATLAB as access to all the students. So, in MATLAB we can one command we can find out the covariance matrix. After finding the covariance matrix, what we really require eigenvector and eigenvalue we need to compute. Again we will explain with the formulas, but in the MATLAB we can directly use a simple one formula, and then we can figure out what are the eigenvalues and eigenvectors. Based on that, what we will decide, we will be creating the important we will try to figure out what are the principal components, what are the main variables, what are the main factors, and which factor can be rejected. And after rejecting few factors, we need to recast all the data, right. We will be rejecting couple of factors and we will be recasting the data, and it will turn out to be a new set of the data which will be available to us. So, this is a complete process. Now, let me explain one by one. We say in this case standardization is required because we are going to deal with variable scales, different scales. And then what is our main aim? That make the mean equal to 0 and variance equal to 1. So, now if I am talking with I am dealing with a 1 nanometer scale, 1 mm scale or 1 meter scale, all 3 can be analyzed simultaneously. So, it will not really affect the scale, will not affect the analysis to us, because we are going to deal with a mean 0 and variance 1, right. So, in the situation whether I am dealing with a nanoscale or micron scale or meter scale, then the results will be will not affect that kind of scale. So, now and after this, what do we say that in the covariance matrix we try to figure out what is association between the pairs, whatever the variables we are choosing, pairs of the variables, and then we need to really interact whether the correlation is a positive, correlation is a negative, correlation is a very strong, and correlation is a weak. We need to really judge. So, this way we think creatively. We have so many data, but we are looking from different angle. Oh, can I make it mean 0? Will I be able to make a variance 1, or will I be able to find out the relation? Is it a strong relation? Is it a weak relation? Is it a positive relation? Is it a negative relation? Again, the theme here is only linear relation. If we want to cross the linear relation, we want to go for other relation, PCA will not be suitable. Basic assumption in PCA is a linear relation. All the variables can be utilized for them developing a new variable, and but the summation will be there. So, the new variable will be basically a kind of a linear summation of existing variables. Now, another one, as I mentioned, that we need to find out the eigen the vector. So, we will be using eigen decomposition, which is already the methods are available in MATLAB. Now, coming to the how do we select a principal component, that is why we say that we try to figure out the eigenvalues and then try to arrange eigenvalues in a decreasing order, right. So, we will have a highest eigenvalue, the next highest one, and slowly towards the bottom will be almost a negligible value, right. And then we will be keeping only one subset of principal components. So, if I find 5 eigenvalues, lambda 1, maybe say lambda 1, lambda 2, lambda 3 and lambda 4 and lambda 5, and I am assuming the lambda 1 is something like a highest value, lambda next highest, lambda 3 is the next highest, and then lambda 4 and lambda 5 are very low value. So, I can reject this. I say okay, now we will be dealing only with these 3 lambda. So, what will happen in this manner? It will reduce the dimension. So, it started with a 5 dimension, now I am able to reduce to the 3 dimension, of 5 variables I reduce the 3 variables, or making a 3 new variable, which is a combination of earlier maybe existing variables. So, in this case we are retaining few principal components. So, this is what we say, this option reduces the dimensionality, which is the main aim, and moreover it is keeping the most of the relevant information. So, it will try to minimize the noise, but keeping a good signal with us, right. So, reduction in dimension and increase in a signal to noise ratio will happen in this manner. Now, as I mentioned, there are some sort of limitations. So, what we are saying here, PCA is suppose that a linear relationship between the variables. If there is a non-linear relation, PCA cannot be utilized that way, right, and that is why it may not work well with a data set that exhibit a non-linear pattern. So, if there is a strong non-linearity, PCA will not be utilized for that purpose. However, the principal component analysis really gives a good understanding, good brainstorming, good way to think about whatever the data we have, and then if we are going out with a new set of the data or maybe the new experiment which we really require, how to start those experiments, which variable will be really important. So, this data and this kind of information we can get from a PCA. Now, I will just try to give a simple explanation of PCA, and this has been already also the literature indicates that the Duke University also in their website there is a one lecture 15 principal component analysis. Basically, they have tried to teach this topic in a very simple manner. What they say that we many times we have a scattered data, and the data has been plotted on x and y graph, and you are able to see that this the dots or maybe say empty circles or hollow circles, and these are the datas. Now, this data is a kind of a random data, we are not getting very good information what kind of relation is there between x and y. So, what they did a kind of they applied PCA, and then after PCA they figure out instead of the u, maybe say u bar, some new axis, and then where the most of the data are lying. So, and then orthogonal to that we will be having almost no data as such over side, right. So, the orthogonal component can be rejected, and then x y can be plotted on the maybe along the u. Of course, for plotting purpose we can use a x y, but at least now we are going to get a linear relation, right, much lesser variation. So, that is what they try to figure out which line the u or u prime will be really giving the best results among the whatever the data we have collected. So, this is what they try to explain by this. Now, in my view, what I try to explain in other words, we say in this case we try to determine the covariance matrix from externalized data. So, that to represent the connection between x and y variable, right. So, we try to externalize the data, we figure out the covariance matrix, and covariance matrix will tell what kind of relation x and y variable have, right. And then for finding the principal component of finding the u prime axis, we will find out the eigenvalues, and of course, the method eigen decomposition method will be utilized. We sort these eigenvalues and then in a decreasing order to find out what are the eigenvalues or eigenfactors, or maybe say an eigenvector is important and what are the elements of importance. So, that can be figured out, and then we can choose, as I mentioned, the lambda 1, lambda 2, lambda 3, maybe in this case suppose there is a lambda 1 and lambda 2 only, and then we can say which one is better. Is it a lambda 2 is far above or greater than lambda 1, then we will reject the lambda 1. So, this is a way now this as I introduced, we will explain the one complete example, again we will return back to these two figures. So, how we are doing it. Now, let us start this complete process. How do we start PCA? We say the first is the standardization. Now, we need to do standardization, how it is done. Generally, it is taught in almost all statistical method, even in the class 12, maybe you must have studied this in the class, in the first year classes also. We do have a data set and data number 1, data number 2, number 3. So, we can say that is the value x. We try to figure out mean value of the data column or whichever we are following and divide it by standard deviation. So, this is a normalized z value. Now, mean, how do we find out the mean value? We know that sum of the terms whatever divide by total number of term will provide average value or mean value. How do we find out the standard deviation? We say that there is a x value whatever we mentioned value x minus mean, and then we square it. So, that negative positive everything gets summed up, and then we divide by n minus 1, and is a total number of the terms which we are using in this ways. However, in a MATLAB we do not have to calculate, so we say only normalize and then we will get a results. Now, let us take one example, this is we have picked up the table from literature or on the online on the site, and then you can see there are 4 factors, that is why we are choosing here 4 variables and 1, 2, 3, 4, 5. So, there are 5 observation. Now, observation can be many, variable can be much lesser. I can take 2 variables and 50 observation, there is a possibility, right. So, we are making some sort of matrix and we say there are 4 variable, f1 is a variable, f2 is a variable, f3 is a variable, f4 is a variable, and then along the column 1, 4, 1, 4, 5 is something like the observation or value which we are getting, right. Now, in this, as I already explained, that standardization stage is very important, it has to be done. And I also mentioned in MATLAB that has inbuilt algorithms in this manner. So, we do not have to do too much, but we need to understand. We make sure the variables with a greater range of variance do not outweigh with a lesser range. What is the meaning of that? If you look at the F3, F3 has a higher value 3, 6, 3, 1, 2 compared to the F4. F4 has a 1, 3, 2, 1 and 1, 3. So, it is almost kind of half. It should not have to happen that F3 really outweighs F3 because of the values. Just to avoid that, that is why the standardization is required, and I already mentioned we can deal with a 1 nanometer scale, 1 micron scale or 1 meter scale also. The standardized variable enable a PCA to concentrate less on absolute values We do not worry about absolute value, everything is standardized and normalized, and then it is everything is in terms of in relation with a mean and a standard deviation. So, what we say in the PCA to concentrate less on absolute value of the variable and more on relative pattern and connection between these. So, that is why the standardization is done. We do not want really to happen other way, right. Now, each variable will have a 0 value, 0 mean and unit variance. As we have already described, the standardization is really required for the PCA. Let me again explain in slightly different manner. We say standardization stage make sure that variables with a greater range or variable do not outweigh with those with a lesser range and variable. So, for that purpose we can take example of the F3 and F4. You can see that in F3 the values are on higher side 3, 6, 3, 1, 2, while in F4 values are lesser 1, 3, 2, 1, 3. So, kind of half of the values only. Now, if we do not do a normalization, quite possible F3 will get a more weightage compared to the F4. So, that is why we really require a normalization, and then we say that PCA with this kind of thing PCA concentrate less on absolute values of the variable and more on a relative pattern and the connection between the variables. And another one as I earlier mentioned also, we need to make sure that each variable has a 0 mean value and unit variance. So, it will turn out to be the better results. Now, just for the understanding purpose, let me explain that we can plot F1 versus F2. I do not get any pattern as such. You look at that F1 the first reading F1 is a 1, and then we get a value for F2 5 and value 4 also. So, there are two values 1 and 4. Now, when the F1 is a 4, we are getting two values and this is a F2 equal to 2 and F2 equal to 4, right. So, they do not follow any pattern, and when these type of kind of data are there, naturally we need to do a PCA analysis on that, so that we get a better results. Similar pattern is also in F3 and F4. You can see here in F3 when the value is a 3, we get a F4 equal to 1, when value is a 1 again we get a 1. Don't know as such any the formulation is happening in this. Now, coming to the value 6, here you can see 6 and here the F4 is equal to 3. So, they do not follow any pattern as such. That is why the PCA is very suitable for this kind of analysis, on this kind of data analysis. So, how do we go ahead? As I already mentioned that Z is a normalized variable, we can get mean value, we can get standard deviation, we can get based on the data, and then when you write MATLAB code, we can directly get a MATLAB code and then we can utilize it a MATLAB code. However, just for the completeness, we have written one small code to find out these values. How we do find the value of this? The mean is value has been given, and matrix has been first entered. Matrix is you can see 1 5 3 4 1 5 3 4 semicolon, then 4 2 6 3 4 2 6 3, then 1 4 3 2 1 4 3 2 again semicolon, then comes 4 4 1 1 4 4 1 1 5 5 2 3 5 5 2 3, right. So, these are the matrix has been given here. Now, coming to the mean value, what is the mean value? We need to find out the mean value of F1. We do not want the value mean value of whole matrix. Here the mean value of variable F1, right. We are not talking about whole the complete matrix. So, how do I find the mean value of the F1? By this call, right. So, we are here and then the column has all the value 1 2 3 4 5 and the 1 is a the first column F1. Similarly, mean of column 2, mean of column 3, mean of column 4. So, simple we can find out those things. Then again we can use a standard deviation formula which is inbuilt in MATLAB. So, the way we have calculated the mean, we say standard deviation of the first column, standard deviation of second column, standard deviation of the third column, standard deviation of the fourth column, right. So, this is done. Now, coming to the standardization, this is the formula which we know, and then we can write on this. So, you can find out this one. We are writing the column 1 minus mean value of this column 1 and then divide by SDM, that is a standard deviation, right. and then again we are going for the second column, we are going for third column, we are going for fourth column. Here the new term is coming the 3, right, and then what is the meaning of 3? However, first when we as we have not given a semicolon, so it will display immediately when we enter. You can see here that matrix 5 by 4, 5 rows and 4 columns. Then we have a mean value, every column will have a 1 value. So, it is a the mean value matrix is a 1 into 4. So, that means initially F1 has a mean value 3, F2 has a mean value 4, F3 has a mean value 3 and F4 has a mean value 2. Now, coming to the standard deviation, again for the each column or with each variable we have a standard deviation. So, for F1 standard deviation is 1.8708 and then F2 has a 1.2247. That is now for F1 and F3 have the same standard deviation. So, this gives the impression one way, oh maybe is it F1 and F3 are almost same, you can look at the mean values same, standard deviation same. Question comes whether F1 and F3 will have a similar kind of weightage on or effect overall on the process. So, that need to be analyzed. Now, once that is done, now we as I mentioned here the Z and then here we are finding the normalized matrix. So, instead of this top matrix which is the matrix 1, I can say we are finding matrix 2. Now, you can see there is a huge variation, right. Here it is value is a minus 1.067, then 0.535, then minus 1.067, then 0.535, 1.0769. Now, if you take a mean value of this and standard deviation of value of this, then what we should get, mean value should be 0. So, that means whatever this new matrix mean value of this column mean value should be 0, this column mean value should be 0, this column mean value 0, this should be 0, this column mean value should be 0. Easiest to check, minus 1 plus 1 minus 1 plus 1 is 0, right. So, however, we can recheck also the mean value in each column turns out to be 0, standard deviation in each column turn out to be 1, right. Now, what is this 3 and then what we are doing here, generally we are trying to keep a restriction on number of decimals, and that is why here we are keeping only up to the 3 decimals, and that is what a rounding of up to the 3 decibel has been given here. Another one that we can say the format we can decide directly short G, and now if it is a fixed format by default some MATLAB is been there, or we can change those things also. So, short fixed decimal or maybe some sort of scientific notation we can use this kind of format for the MATLAB program. Now, that is done. Now, we have normalized the variables and normalize each variable will have a mean value 0 and standard deviation or covariance and the variance equal to 1. Now, next step is to find out the covariance matrix, and covariance matrix is that we assuming the 2D x y, and then we say the first element will be covariance of x and x, which maybe turn out to be the variation the parameter 1 or maybe parameter 2 or parameter 3, and that is been mentioned. Then another one is a covariation between x and y. We know very well covariation x and y x should be same, and then covariation between y and y. So, how do we calculate this? Of course, there is a standard procedure, but we write out here the x, what is the deviation of x with the mean, and then what is the deviation of y with the mean. So, that is what has been mentioned, and then that product will be summed up and divide by number of points minus 1. That will give the covariance for the Punnett matrix. Now, if we replace x with a y, then will turn out to be the first column itself, which the self variation will come. In this case, that is why we are saying the variance 1 is equal to for the normalized matrix Z for the column 1, and then we are giving in this case Z square divided by 4. As I say, number of points are total 5, we need to divide by 4. So, variant 1, variant 2, variant 3, variant 4 has been mentioned here, and then correlation F1 and F2, F3, F1 and F3, F1 and F4, F2 and F3, F2 and F4, F3 and F4, and all are the related same, right. F3 and F1 will be same, F4 and F1 will be same, F3, F2 will be same, F2 and F4 will be same as the F2 F4, right. So, these are the thing, and then we can find out the complete matrix, and then we can round up this to the 3 decimals up to us. So, what we want, this is the what we can calculate a covariance matrix FC. However, if you want to utilize only the MATLAB code or MATLAB inbuilt algorithm, we will write down the new matrix name, but for time being we are saying that FC, which has been calculated via MATLAB, that is what the FCM round, and covariance matrix simple. I can write directly Z, but we want to compare up to the 3 decimals. So, that is the 3. Otherwise, you write only whatever the normalized matrix you have, you write down the COV of that matrix, covariance matrix will be available, right, and that matrix has come something like this. So, this is what we wrote a program, and this is a what MATLAB has generated a program, generated a matrix. You can see there is a complete matching, and then all diagonal element need to be 1, because 1 to 1 relation will be same. And then the F1 will have a same relation with F1, F2 will have a same relation with F2, that means equal to 1, will not be having other things, right. While other cases it can be negative, it can be positive, it can be very low value, it can be very high value also. You look at here, there is a point the 0.218, which is a negative, that means a reciprocal relation, and 0.535 means a positive relation, both when the parameters will vary together. Now, in this case second column, all 3 correlations are negative, and except the diagonal element 1. And in this third column, first 2 are negative, last one is a positive, while in this case there are 2 are the positive and 1 is a negative, right. So, we are talking only about the off diagonal elements, and then what is the meaning of that? We say the type and intensity of the link, whatever the value which we are getting, or link or value of the variables can be inferred from a signature, what is a negative sign, a positive sign, and what is the magnitude of the covariance. Higher the value of the magnitude of covariance means it will have a more impact, low value means it will have a lesser impact, right. And another mention that the positive covariance denotes that there is a tendency for both the variable to rise or decrease, whatever value the co-had. Okay, so then both the variable to rise when one rises, or maybe second variable will rise when the one variable is rising. Another one is that we may get a covariance value equal to 0 also, which indicates there is no relation between 2 variables, will be very useful. However, because the whole PCA is developed on the linear relationship, we can't say that they do not have any relation. They may have a linear relation other than linear relation. Fine, we are 100% confident that there will not be any linear relation between those variables if the covariance is equal to 0, right. If it is a negative, naturally one variable is increasing, other variable is decreasing, but when the value is a positive, both the variable will increase or decrease simultaneously, they work in tandem with each other. So, these are the just inference from a covariance matrix. However, I believe that it when we look at the old data, or maybe the data which are kind of archived in the data book, or maybe in some libraries, those can be we can think on those data and we can come up with a better and better relations. Now, the next one step is that to find out the eigenvalue, eigenvectors. So, this is again the MATLAB code, we can find out eigenvalue and eigenvector, and has been mentioned shown results here, eigenvector and eigenvalue. Now, what is more important for us to figure out eigenvalues, or maybe give a descending order or ascending order. However, we will be preferring descending order. You can look at the first eigenvalue, the 2.3169, very high value. Second eigenvalue is a 1.164, third eigenvalue and fourth eigenvalue are with the same 0.24247. So, if I try to figure out what is the percentage contribution of these eigenvalues, I can figure out. Now, first variable or the first F1 has the highest contribution 58.9. Second variable has a slightly lesser contribution compared to first, almost 50%, that is a 29.02. However, third and fourth which have almost same kind of contribution, that means if I reject this 12% contribution which is happening because of F3 and F4, at least I can get a good 88% results if I go ahead with only F1 and F2. Now, I can reject one variable, I can say reject only f4, but values are more or less same. If the value then the f3 would have been like 10, 15, then I would have rejected f4. But here both the values are almost same, and it is not very difficult to segregate which variable should be removed. For time being, we can really remove the f3 and f4 together. We say that almost they have a 12% contribution, while first f1 and f2, which is a major contribution, 88%. And that is what the way principal components are decided. So, in this case the principal component for S is f1, principal component is f2, right. So, principal components are the variables created by linear combination of initial variables. Principal components are uncorrelated. If you try to plot f1 and f2, they will not be any relation among each other, right. And then we say the most of information contained in initial variables can be compressed or can be recasted, can be replotted in these variables. So, that is possible. That means, instead of thinking about x y coordinate, if I think about x prime coordinate, y prime coordinate, I do some sort of transformation or maybe say the rotation kind of thing, 5 degree, 10 degree, I can change a coordinate system, I may get a better relation, I may get a better results on that. That is what the meaning of this principal component analysis. We try to figure out alternative axes which have a more number of data, and then we get a more meaningful results. Now, we say mention the word recast the data, and that is why the recasting data can be done. Now, if I assume that there are two principal functions or factors or variables, and we find f1 and f2, that also is possible, we can do that. However, for the recasting initially only the whatever we calculated f1, f2, f3, f4, that means these all 4, if I assume initially all 4 eigenvalue are important, 100% variable are important, and then we still can recast the variables along those axes. So, if we do that the recasting of data along the principal component analysis, or in this case we are assuming all 4 this values are useful. Suppose one is contributing 58%, other 29%, third and fourth 6%, all are those suppose important for us. And so, we recast the data, recasting data is possible we multiply this normalized matrix with eigenvectors, and then we get this kind of a matrix. Now, this is a recasted matrix. If you look at the recasted matrix, this third the 3 elements and the top 3 elements are negligible, and the 4th and 5th element have some sort of importance, but both are the same. Now, if we go ahead only with the 2 important, we say that okay, we are happy with 88% results. If we go ahead with that, then what will happen, we will be getting only first 2 columns which are very important for us, and then still we can recast the whole matrix based on that also. So, instead of going for the complete eigenvector values, we can recast only on the first basis also. So, what we say that based on the percentage contribution, select the most contributing component without losing essence of the data. If we choose this f1 and f2 at the first column and second column, and then we count only those variables, and then we recast, still we can find out the good data without really losing the information. So, this is a right way, we say large data set can be reduced without significant loss. I am using the significant loss because in this example we found that if we reject to f3 and f4 in the values, or maybe say eigenvectors and eigenvalues, then we will have around 12% loss, but it is not a very significant loss. And we say this is a significance of, or this is the importance of principal component analysis. So, this is the main utility of principal component analysis. And then if you compare this new matrix which has been transferred with to the on the plane of principal component the axis, then what we are able to see, this is the original data, a normalized matrix, and then there is a huge difference between this and this matrix. In the third and fourth which was really showing high values, now it has come down to the first value is 0.09 something, second value 0.14 compared to earlier very high values. So, this is there will be difference. Now, we will just consider our earlier one example where we found a lot of difficulty in plotting the data, when we were saying that digitization and plotting and understanding the relations are important. So, we are reconsidering that example as such. This was covered in my previous lecture. Now, we were concentrating on this diagram. We say there are many data, and then you look at there is almost 34 data, red color data, but we do not find any pattern, and then we want to really use a PCA on this to get a better and better results. How do we go ahead? Earlier we tried to use a linear relation, polynomial relation, exponential relation. We found in linear relation regression coefficient was 0.86, and I also mentioned that wherever the regression coefficient is lesser than 0.9, we should not consider. And coming to the polynomial, also that regression was very near to 0.9. So, naturally that is why we really required to look at the PCA, whether PCA can improve that correlation, can we get a better results from that point of view. So, this is what we wanted to analyze. Now, if you look at this data and then we say that now factor 1 and factor 2, only there are two the factor 1 is maybe electric corrosion period, and factor 2 may be the energy when we are trying to plot it, and we have a 34 and the data in this case. So, period has been mentioned here very clearly up to the 98 days. Of course, so this has this red color sign has been shown because we could not accommodate in one column. So, we say that 54.23, after that 51.78, and of course, so these data are not available to us. So, what we did, we digitized data, right. So, we try to extract the data from a graph itself, whatever the values are given, and this is what I was mentioning. From an existing literature we can really get the results, we can digitize, we can get the data, and then we can use a PCA to understand how to improve the system. So, this is what has been done, 34 data, and the last value in this case has been shown as a 98.09. These are the number of days, and then F2 has been shown as the energy level, and then if we use this matrix, now here only there are two variable and 34 as a number of observation. So, which was earlier was a 4 variable, and a previous example which we covered in this lecture, 4 variable and 5 observation, while in this case there are 2 variables, only 2 variables and 34 observations. Now, if you do it, now we can get a mean value, we can get a standard deviation, we can get a normalized matrix also. Again here we use the word 3, and the variable it will be up to the 3, or maybe say the decimal will be up to 3. So, this is what matrix has come, maybe say that the 2 by 34, and there are only 2 columns and 34 rows in this case, and these are the values which has been given to us, or which we could calculate from this point. Now, if we try to go ahead with the covariance matrix, again we will follow the same procedure. Covariance in this case F1 versus F1 will be the variance and F1, and F2 and F2 variance of F2, while covariance F1 and covariance F2 and F1 will be same. So, these values too will be same. That is why we are saying the variance 1, variance 2, F1 and F2, and FC can be calculated using this one. Again we have calculated also using the MATLAB to get the same results. And then in this case overall this covariance matrix, which will be the kind of a square matrix, it depends on the variables. If the variables are 2, naturally this matrix has to be 2 by 2. So, it is a square matrix. If variable will be 4, then a square matrix 4 into 4, that is the covariance matrix. And we are finding the same value as what we calculated from our algorithm on the MATLAB. These are values given. Now, we calculate eigenvalues, and eigenvalue if you can see here, first eigenvalue is a 0.069, while second eigenvalue is a 1.931, which is significantly high. Now, if we go ahead with the percentage contribution has been shown something like this here. The first eigenvalue gives contribution only 3.45, while second the eigenvalue gives a contribution of 96.55, significantly high. Naturally, we can neglect this value, in this situation, and that has been shown in a figure kind of a bar chart over here. You can see the 96.55 has been shown very significantly high, and this is a kind of negligible. So, we can neglect this variable as such. Now, going ahead with recasting the data, we recast the data and the data has been shown in this form. This is first 17 data and then next 17 data have been shown over here, right. So, this is what has been now there is some sort of pattern is visible. Now, if we plot it, what we get, this was initial plot, right, and now this is another plot which we are getting with the recasted data. Now, here you can see that the regression coefficient is turning out to be like a 0.965. Earlier regression coefficient was something like a 0.86. Now, this is what the beauty of this PCA, that linearization or maybe better linear relation can be recasted or can be found using the this method. Now, if we instead of going ahead with a standard deviation, I mean the values to be plotted on x and y, we find suppose number of points, maybe there some slightly different variables in this case or maybe other variables. So, in this case we plotted against the number of data point, we found that this value has further improved. Now, it has gone to the 0.97. So, even the thinking slightly different, maybe the different variables can be judged, or maybe we are trying to analyze 10 different resources and then we can choose which one is giving the best results. This is what the beauty of PCA. So, we can say variables are in this case are negatively correlated, that is why the negative sign is coming. These variables are negatively correlated, one variable tend to rise while other is tending to fall, right. So, that is what has been shown here. And second thing is that the new line which we are getting, the new line contain more number of data points around it. Earlier data points, naturally the variation was more and that is why the correlation coefficient was lesser, while here in this situation the more number of data points are around that line. That is why the PCA generates a now a new set of the axis which contain which that makes it easier to evaluate the data and keep track of how observation varies. That is why we are getting better and better relation. And our lecture we started with this example, we say that data are scattered. Can we really change the line or maybe curve fit line in this case, where the more number of points can be accumulated or will come around that. So, this is what we had mentioned earlier, u and u prime here. While in this case you can see the old data, the blue color line, but orange color the line is different. And when we come with another the variable, instead of going with the normalized values, instead of going that we go number of points, we are finding something different. So, this is the beauty of the PCA and it should be utilized even though we have a number of data available in literature that can be gathered and can be utilized using PCA. Thank you for attending this lecture. Thank you.